Hello again. Well, in my haste to get the Khan Academy challenge all finished and completed, I rushed and realized that I made a slight mistake with the moon orbiting around the Earth. So I wanted to just correct it because I felt dissatisfied with it. And for anyone who watches this, say my future students, I think it's very important that you understand how to correct this mistake. And also, I'll use this opportunity to explain it more in depth because I did not explain it in depth to begin with anyway. Okay, so what I had to begin with was this equation. And this equation essentially is centered not around the Earth center, but actually 0, 0. So that's the first problem. And the next problem is that it's not a circular orbit. Now, the funny thing is the moon's orbit is not circular anyway, so it's probably better to leave it as an ellipse, but I've just made it a circle because that's what I intended to do. So let's look at the new equation. This is now centered around the center of the Earth, which is 0, negative 3,177.3, which is taking from here 0, negative 1,300, negative 3,177.3. And this is similar to what was done before, but I'll explain why that works now. Okay, so let's start by making the circle itself, which is x squared plus y squared equals 1. Now, what we can do to represent all the points on that unit circle is write the following and add a slider. Okay, so let's start this at 0 and let's go to maybe 12.56, which is 4 pi, so that's 2 full revolutions. Okay, so here you can see that cos 0 is 1 and sine 0 is 0. Okay, so as the angle increases, as we can do here, it starts revolving around. So at this point, right at the top, and we'll just approximate that it's right there at 90 degrees. Okay, and this is the radian format of this. But cos 1.6, which is about 90 degrees, is going to be 0, and sine 90 degrees is 1. Okay, and if we just let that play, you'll see that circle going around the unit circle. Okay, so what we wanted to do is pretend that this origin is the Earth itself. Okay, maybe I can make the Earth by doing that. And what we want to do is have an object revolving around this with the center as this point. Okay, with the center as this green point. So how do we do that? Well, first of all, let's make a circle centered around the point 1, 0. And we can do that by x minus 1 squared plus y minus 0. We don't need to write the 0, but I'll do it for now. Squared equals, let's say, 0.2. Okay, make it a little smaller. So there's that circle. Now we want this black circle, let's say that's the moon, for example, to revolve around this path. Okay, so instead of having the center as 1 and 0, we need to make it dynamic, okay, which involves a slider. So I'll use the a above. So we want the center to be this point, which corresponds to cos theta. So let's put cos a, so it matches the above. And the y needs to be sine a. Okay, so now let's see what happens when we hit play. And you can see that it's revolving around as we want it to. Okay, so now the other part to realize and understand is that I multiplied it by a big number. Now, this number actually is not just some random big number. That number was chosen because that's the approximate distance away from the Earth that the moon is. This is all to a different scale than like in real life, but you can play around with that. I actually encourage you to look at the size of the Earth and the moon and maybe fact check this and to see if it's approximately correct. Okay, so what we can do is let's multiply this by 3 and this by 3. Okay, so if we hit play, you can see that this green one is now going around at a diameter of 6 or a radius of 3. Okay, so similarly, we can change this to a 3 and this to a 3, and you will see that it's now revolving around. It's going backwards, and that's fine, but it's now revolving around further away. So we can just put whatever number we want here to make it go further. Now, something interesting, I mentioned how the moon's orbit is actually an ellipse, okay, and I don't have the exact numbers here. I'm sure we can look that up and figure it out, but what can we do to make this an ellipse and not a circular motion? Okay, well, let's just play around with this. Maybe get rid of that 3. Okay, and let's see what happens here. You can see that now it's going up to 3 here and negative 3 here and going 1 right and 1 to the left. Okay, so there's just one more thing I would like to show you, and that is what if we didn't want it to be centered around the origin at 0, 0, but rather a different point, let's say 1, 2. Okay, so we can change this to 1, 2, and let's move everything. So that means this gets transformed over here, -2. Okay, so that moves that circle. Okay, let's go back to the original for now. Okay, but how do we have to transform this point? Okay, well that means everything moved right 1 unit, so everything on the x coordinates moved 1 right unit, so 1 plus that, and this is 2 units to the right, so, and sorry, 2 units up, so 2 plus sine A, that's on the y axis, and then similarly to these, just going back to the original again. Okay, we want this to move like that, y minus and -2. Okay, and let's see if this works. Okay, and we can see that it is correctly rotating around a different point. So hopefully this clears up any confusion, and I hope you now understand a more in-depth procedure on how to make this work, and feel free to play around with it. I'll leave the link to this file below in the description so that you can play with it. Okay, so have fun and enjoy. Thank you.